Hi, my name is Bruno Penteado. I'm a PhD student from University of São Paulo at São Carlos, and I'm here today to present my paper, Correlational Analysis Between School Performance and Municipal Indicators in Brazil Supported by Linked Open Data. I would like to thank this opportunity to present this work remotely, and I really appreciate for this opportunity. Thanks a lot. So let's go. Here are my technical motivations to perform this work, to study more the influence of socioeconomic factors in educational management literature and the increasing opening of governmental data here in Brazil, but where we still have many departmental silos. You have a lot of different ministries that collect a lot of data, but uh, in some parts they are not related to each other, and this integration is a difficult task to perform. And to try to address this issue, I try to use the linked open data technologies to merge these data sets and to provide some semantic information over this data and to allow some inferences on this data. So here it's a personal motivation where I see that technology is not the answer for everything in education. So what I try to bring here is that one important branch or one important niche for educational technologies is for guiding educational policies and practices, and so to support the educators to perform their job more appropriately. And with that, to build some tools to support this decision making and to influence the educational policies, because once a policy is set, many things can change, including the adoption of technology. So I see as an important first step is to guide and influence this decision making and influence these policies. And here we have another motivation for me, that it was an analysis that I made last year, where I crossed some data from ENEM, which is a large assessment for high school here in Brazil, and I compared the social and economic level from schools and their scores, their respective scores. Each point here in this graphic represents a school, their aggregate scores, their student scores and their aggregation, and their aggregated socioeconomic level, ranging from very low to very high. Although there is a lot of variation here in these levels, we can see that there is a huge difference when you go up in this socioeconomic level. So I would like to dive deeper in this specific subject. As previous work, here we have in both in educational and computer science settings, many studies show the strong influence both from schools, from school socioeconomic variables, and from municipalities, where the schools are located. And also the negative effects of poverty in academic performance. But you see, these studies are very important, made in the last decades, but they all use offline and, if I may say, non-ontological data to conduct this analysis. And in a more technical sense, there are some studies on the integration of performance and census data, the academic performance and census data, the integration of multiple web applications and different processes for data publishing. So this study fills the gap of using different indicators to perform the correlation analysis and bringing the LOD technologies into the mix. Also here in Brazil have many popular websites providing open information, but you see it's a lot of information about a lot of schools. We have currently over 150,000 schools functioning in Brazil, and for every one of these schools there's a lot of data, so it's a huge challenge to present this information. And they do a quite nice job providing a human-friendly environment, but no easy access, automatic access to perform this kind of analysis. So the objectives for this work is to select open data from the web, both from academic performance of public schools per municipality and the contextual indicators on the municipalities, and extended those data from the using the DBpedia information and make them open following the LOD principles. And as an application of this process, a case study, descriptive analysis of the correlation among the indicators. What indicators did I use here? The first and the most important here is the IDEB, the Brazilian Basic Education Development Index. It was created in the late 90s. It's collected every other year. It was last collected and published in 2013. It was collected last year, but it's not still published. And it measures the academic performance in a school level granularity. And the main indication is the main indicator of education improvement and quality in Brazil. It ranges from 0 to 10, to just like a regular score in school. And it's divided in initial years and the final years. The initial years is from first to 5th grades, and the final years to 6th to 9th grades. And it also is categorized by municipal, state, federal, and private schools. Our main concern here is with public education, so I excluded the private schools, and as there is there is a few set of schools in the federal level, so I excluded this category as well. So I worked with municipal and state levels. And these were the socioeconomic indicators that I used. The Municipal Human Development Index. It measures the income, the health, and the education in different variables. It ranges from 0 to 1. The closer to 1, the better. And it was last collected in 2010. We have the Gini coefficient that measures the inequality or the concentration of income in a given population. It ranges from 0 to 1. The closer to 1, the more distributed is the income, and the closer to 1, the more concentrated in just few inhabitants. So arguably the lower the better. It was last collected in 2010. The Social Vulnerability Index, it's an index that measures a lot of infrastructure variables in a population, the provenance of this infrastructure by the government, and it ranges from 0 to 1. The closer to 0, the better. That is, the lower the social vulnerability. And it was last collected in 2010. And the GDP per capita is the total revenue divided by the number of inhabitants in the population. There's not a fixed range, but the higher the better. These data were extracted from the DBpedia. and the other three were extracted from IPEA, the Institute of Applied Economic Research, a federal agency here in Brazil. And the population was also extracted from the Wikipedia. So according to this very famous 5-star principle on LOD data, we have the IDEB at level 2, the IPEA data in level 3. IDEB is in Excel files, the IPEA data is in comma separated values, and the Wikipedia is already in the highest level. So we try to enrich this original data with this 50 level data from the Wikipedia. So here is the study design for this work. We have the independent variables, the socioeconomic indicators, including the Human Development Index for municipalities, the Gini coefficient, the Social Vulnerability Index, and the GDP per capita, the demographic indicator of population, and to measure over the dependent variables, the educational indicators, the IDEB for initial and final years, and both for municipal and state levels. And here is how I've done all the processing. It all started down there with the data sources from IPEA in CSV format, and IDEB data from INEP with their Excel files. So I processed all this data using OpenRefine, this tool, where I used the feature of reconciliation to extend this data, to enrich this data with the Wikipedia information. It was done by the municipality's name, so it has some issues that I'll explain later, but it was quite a good step here. And all this processing of the filtering data and transforming data and reconciling the data using OpenRefine, I generated the RDF triples, and I mapped it to the ontology that I created. In the next slide I'll show it to you using Protégé, and I mapped those data, those triples, over this ontology, and I exposed this data in a triple store called Dydra. You have the link here, where I could perform the semantic queries for this analysis. And I used here the R tool for statistical analysis, very common among statisticians and computer scientists. And specifically, I used the Sparkle R package for this work, where it could fetch all this data and could process inside the IDE of R as an usual data frame. So it's quite easy to use those tools. So parentheses here, the Wikipedia's information source. We have in Brazil 5,565 municipalities here, the official number. 7 of them had no information on the Wikipedia. 2 of them changed their names. You have the official name and the Wikipedia name, so a gap here. And the main issue was the syntactic inconsistencies here. Some examples include the homonyms. You have São Carlos at São Paulo state, and São Carlos at the state of Santa Catarina. Some name definitions, like you have different letters with the same sound, and the municipality's name are written in each source with different spelling, so it's difficult to do the reconciliation here. We also have some punctuation problems here. We have some letters with accent and some with without this accent, so it's also an issue here. So here is the ontology to describe this data. I have the municipality here as the main entity. It's linked to its state. It has some properties of latitude, longitude, the code for this municipality, their names, and both municipalities and states are linked to the Wikipedia entities using the same as properties. And the municipality has these indicators that I listed before. These indicators have some different properties, like the title, the year of reference when it was collected, and their values. And there are a lot of types of indicators here. As I said before, the economic indicators, the demographic indicators, and the educational indicators. Here we have the educational indicator with two specific properties: the cycle, whether it is the initial or last years, final years, and the administrative level, municipal or state level. And this VCGE, it's a taxonomy for Brazilian data that qualifies this data as educational. It's as simple as that. So we have the correlation matrix for this data, and we can see that some of them have stronger relation, like social vulnerability index and the human development index. Four of the indicators out of the 5 have significant statistic correlations. Just the population have no significant correlation, and when it has, is very, very low. So you can see that population has no effect on this performance data. And we have all the others, ranging from the first years. The initial years are stronger than the final years, and we have the municipal level with stronger effects than the state levels. So it's an interesting information that deserves further investigation. Municipal schools are expected to have more effects on the income, these other indicators, the effects, but the initial years having stronger effects is an interesting thing to analyze. Maybe is due to dropout rates, but it deserves some investigation. The data and the queries are available at dydra.com. You can see it here. You can check and perform some other queries on this data. It's an online and free triple store, very nice. And this semantic data, as I said, is available for queries, both for humans or apps trying to integrate this data. So it brings the confirmation, the replicatory effect of the study's results in educational literature. That is, the better the socioeconomic status of municipality, school, or student, the more likely their academic performance. And the quality of education cannot be analyzed disregarding school and student context. This is a very important finding for educational literature. And to help with that, I used here the LOD technologies to make this process easier. So as a future work, if this project is to be carried on, and I have the data for school data more recently published, with a lot of data as average of student per class, number of daily hours at school, and so on, and to carry some inferences on this data regarding the ontology created. So that's it. My time is due now. Thanks a lot for your attention. Thanks for all the reviewers for the feedback, the precious feedback given to this work. And thanks again for the opportunity to present this work remotely. Muito obrigado. This is my contact. If you wish to know more about this work or use it in your own, I am available and I'll be glad to help. Thanks.